Okay, so these first 4 problems are all asking the same thing. It says, find the slope of the line through each pair of points. So the formula that you want to use for 1 through 4 is y2 minus y1 over x2 minus x1. Now remember, if your top is 0, that means that your slope is 0 and you have found that it's horizontal. If your bottom ends up being 0, remember that's you just write undefined. Okay, so let's do number 1 together. If you're going to use that formula, label your points as x1, y1 and x2, y2. And then we're going to plop those values into our formula. So it'd be negative 19 minus negative 1 over 19 minus 19. And so we end up getting negative 19 plus 1. Remember that second piece will always change sign, over 0, or negative 18 over 0. Now again, if 0 is your denominator, that is an undefined thing, so just write that your slope is undefined. If your 0 is in your numerator, 0 is okay if it's in the numerator, but it can't be in the denominator. So that's what you're doing for 1 through 4. Just calculating the slope, simplify it as much as you can. Improper fractions are fine as long as they're reduced, okay? So that's it for those ones. That's okay, you got that? Yeah. Okay. Now, in 5 through 8, you're still using that same formula. Here it says, find the slope that is parallel to the pair of points. 2 lines that are parallel, what do we know about their slopes? 2 lines that are parallel, they're the same. So the slope you find here is the slope that they're looking for. There's no other change or anything you have to do. So let's do 15 together, or 5 together. So label that x1, y1 and x2, y2. And let's plop that into the formula. So it'd be 0 minus negative 2 over 16 minus 4. So it's the difference of the y's over the difference of the x's. On the top, it becomes a positive 2. On the bottom, it becomes a positive 12. Now, the slope we are looking for should be the most reduced version as we possibly can go. So the slope of 1/6 for this line would be the slope of the line that we want. So the answer is 1/6. Okay, so that's what you do for 5 through 8. The slope you get is the slope you're looking for. Now the ones that we have to start thinking about how we can find it is 9 through 12. Remember here, we want to have the opposite sign and the reciprocal of whatever we find, because 2 lines are perpendicular if their slopes are opposite signs and reciprocals. If we multiply them, we should always get negative 1. That's a way to kind of check your work. Okay? So 9 through 12, oh wait, I'll scooch back. So 9 through 12, we have some other things that we have to do. Okay? So let's do 9 together. We still have to do the calculation for our slope using our slope formula. So label your points, x1, y1, and x2, y2. Now, it really doesn't matter which you call x1, y1, or x2, y2. I just kind of go from left to right and whatever happens, okay? So our slope for number 9 is 9 minus 9 over negative 20 minus 17. So we get 0 over negative 37. Now, I was hoping one of these came up like this. Bless you. I was hoping one of these came up like this. This is a vertical line. So when we go to find the perpendicular slope, we have to flip it and change the sign. But are we allowed to have 0 in our denominator? No. So what's interesting is if one line has a slope of 0, it's perpendicular to a line with an undefined slope. Because when you go to flip it, you can't. So undefined and 0, the slopes are always perpendicular to one another. So that's just a weird case because our y values matched initially. When we go to flip it, we get something undefined, okay? And because this is horizontal, or I'm sorry, no, our original is horizontal. This is vertical. Sorry about that. This is vertical. And a vertical line and a horizontal line are perpendicular, okay? And then for 15 through 16, it is in slope-intercept form. You're using y equals mx plus b. And all you got to do is pull out and write me down that coefficient. So like 13, I just need, the answer is -5. So nothing more than that. 14, you could rewrite this if that helps you as y equals 0x minus 1. But it's horizontal, so it always has the same slope. So there you go, okay? And then 17 through 22, it says to find the slope of a line parallel to each. So like 17, our slope is -1. So the slope we are looking for also will match and be -1. So parallel lines have the same slope. Parallel lines have the same slope, okay? It's not until you get to 23 through 28, the ending, they're asking you to find perpendicular. So pull out the slope that you got. In this case, it's 1. Remember, if you can't see the coefficient is 1. And then all we're going to do for the slope we want is change its sign and flip it. Well, what is 1 over 1? Yeah, it's still 1. So this case, it would be -1. And so you can check your work. The multiplication of the two things should give us -1. So the slope we're looking for there has to be the opposite sign and the reciprocal or the flip of it. Okay, the opposite sign and the flip of it. Now, let's do 27, and then you'll have the rest of class to work on this. Look at 27. The way that it initially is looking, it's not in slope-intercept form. So let's take that x and scooch it to the other side. So it would become a -x on the other side. So we would have y equals -x plus 5. So initially, our slope for this one is the coefficient -1. Now that's the slope of what we got. They're asking you what slope are we perpendicular to. So you're going to change the sign to a positive and flip it over. And so it would be +1 as an answer. Okay? So that's all you're doing. This shouldn't take you very long. When you're done, take a picture of it. And then check Google Classroom. Are you missing anything else? Progress book has been updated. Your quiz grades are in there. So just take a look at that. And that's it for what you're doing today.